In the era of Industry 4.0, innovation has never been more paramount. Welcome to Kowint. Our mission is to be a reliable green energy manufacturer. We take pride in our advanced production facilities. And today, we will take you through our advanced production process. Let's get started. Kowint is proud to boast state-of-the-art production facilities. Our footprint in the power management and energy storage industry is significant. At full capacity, our automated production lines can generate an impressive 157 megawatts of power management and energy storage solutions annually. C is our manufacturing workshop. We have two fully automated production lines supported by a manufacturing execution system. These production lines provide a seamless transition from raw material input to finished product shipments. Equipped with advanced domestic production equipment and sophisticated processes, our lines shows the latest in smart solar manufacturing. Kowint's module aging workshop is equipped with 16 low-voltage aging chambers, 3 high-voltage aging chambers, and 7 other aging equipment from leading domestic brands. Our aging equipment is fully automated and integrated with the manufacturing execution system. All parameters and product quality data are uploaded to the MES in real time, allowing for traceability and analysis. All components undergo 2 rigorous functional tests: safe insulation withstand voltage test and semi-finished product full functional test executed by automated test equipment. Upholding the highest control standards, the defect rate of products from our integration workshop is less than 100 parts per million. We have a strict process to producing. Our process begins with battery cell inception. We rigorously check the appearance for any damage, ensuring that all battery cells in the group are the same. To guarantee the quality, we only use cells from reputable manufacturers and have strategic agreements in place. Next is cell sorting. Our automatic sorting machine scans the QR code of the battery cells, testing their internal resistance and voltage, which is then saved to our MES server. This ensures consistency among the cells. Our equipment of the choice here is the cell sorter, renowned for its high precision resistance meter. This automatic tester keeps the voltage deviation under 5 millivolts and internal resistance under 2 milliohms. Then comes pole laser cleaning. Using laser technology, we meticulously clean the cell pole surfaces to ensure they are free from oxidation and dirt, guaranteeing the quality of welding. We then proceed to cell stacking, where the positive and negative poles of the battery cells are arranged according to the product structure. Each cell's QR code is scanned, binding all cells in a group together for easy product traceability and data retrieval. The next phase is module pre-pressing, using automatic pre-press machines, similar to those in automobile power batteries. We conduct pre-pressing and install end plates and steel rings to ensure the consistency of module dimensions. Our steel rings are made from custom steel. We use a high-precision CCD vision inception device to identify cell module characteristics, check the cell polarity for errors, detect positional deviation, and read the 2D barcode of the cell module. The data is uploaded to the MES. establishing a basis for further station procedures. Next, we install the brackets. The brackets and the battery cells are linked in the MES, which also automatically verifies the quality of the previous process. Our brackets boast a flammability rating of 94V0, meeting our product's energy storage requirements. In the laser welding stage, the bracket's barcode is scanned and the welding data is associated with the battery cell module in the MES before it enters the laser welding equipment. We use a 6 kW laser in our welder, which automatically identifies positions and measures height. We conduct a pull test every 2 hours to ensure the reliability of welding. After welding, we clean all the welding points with an industrial-grade vacuum cleaner in the welding cleaning and inception stage. Our next process is collector board welding. We replace traditional weld harnesses with PCBA, using laser welding to connect the PCBA with the battery cell module. This area is inspected every 2 hours to ensure quality. We then move to collector board testing. Here we test the voltage of each string in the module, ensuring a voltage difference of less than 10 millivoltage. The MES binds the collector board with the battery cell module for future traceability. In module boxing, all electric batteries undergo torque calibration to ensure the torque matches the screw tightening values. The next stage is assembly blinding. By scanning the battery cell module, wiring harness, BMS, and the shell in the MES, we link them together and apply a product serial number. This allows us to trace all bond material information and test data via the product serial number. Then we perform a torque check. We use a torque range to ensure that all screws are torqued to production standards and that they are marked with an anti-losing line. We then proceed to insulation pressure resistance testing. We use 500 voltage for insulation testing and 1000 voltage for pressure resistance testing, ensuring they meet production standards. The results are then uploaded to our MES for station management. We have wiring harness tidying. We maintain neat and organized wiring harness throughout the process. we move on to ATE1 testing with a total of 25 test items. We check for station confirmation, communication ports, and protocols, software version numbers, accuracy of voltage, current, and temperature, charging and discharging functions, temperature rise, serial number writing, DC internal resistance, and more. Following ATE1 testing, we conduct agent tests. We employ high-precision agent equipment to test all products for capacity and lifespan. The MES records the data during the entire charging and discharging agent process, monitoring battery voltage differences, temperature rise, discharge capacity, and voltage consistency. The MES also automatically determines if the product passes the test. We use the MES to bind all parts by scanning to ensure no parts are missing or incorrectly installed. We proceed to ATE2 testing, also known as finished product testing. Like before, we use ATE for automatic testing to ensure the quality standards of the product after aging. We use MES to automatically print labels. This guarantees the three codes align perfectly. At the same time, we bind the accessory pack and the product to prevent any oversights in including all parts. Next is visual inception and cleaning. Our products undergo 2 rounds of visual inceptions. After the production stops inception, quality control reconfirms, ensuring that the product's appearance meets our high-quality standards. Boxing is the next stage, to once again ensure no parts are missed. We have special positions set on pearl cotton, making it immediately noticeable if all parts are present. Finally, we move to QA delivery inception. By scanning the outer box serial number, the MES automatically back-checks all stations for the product and pushes it for QA inception. The manufacturing execution system is the backbone of our intelligent production. It offers real-time visibility, precise monitoring, and control over our entire manufacturing process. From raw materials to the final product, it ensures efficiency, traceability, and quality. It plays a vital role in order management, checking the progress of each product to ensure timely delivery, providing transparency to our customers.